My name is Tony Walsh. Today I will set the scene, deal with transition between the presentations, offer conclusions and summary of the content, and handle the question and answer session at the end. Next. Today's webinar is entitled Data In, Data On. And as you might suspect, it is all about data, where it comes from, how we translate it into physical data carriers such as barcodes and human readable text. Today we are primarily focused on GS1 standards as they are the most universally accepted and used, although there are other organizations such as HIBIC and AABBC that offer other approved data carriers and system structures which can be used in certain instances. The presentation today forms part of a webinar series, and there will be a future webinar entitled Data On and Data Out, which will deal with what happens once we have placed and printed a code on a pack, what happens to the data once we have read it that needs to be used to comply to the standards and the systems of track and trace and serialization across the world. So, as I've said, my name is Tony Walsh. I'm the Principal Consultant at Walsh Consulting, which is a small UK-based specialist healthcare consultancy. I have extensive experience in the global development of healthcare standards, both in pharmaceutical and medical devices. I have been involved in the global development of serialization and track and trace for many years, and particularly the development of coding and data structure that has led to the current regulations, legislation, and compliance standards that we use today. I have worked with and for GS1, EDQM in Europe, and developing European standards as well as UK standards and global standards with GS1 in the UK. And I have been involved with the implementation of healthcare standards in the UK with the Department of Health and the NHS, as has Chris Doyle, who you will hear from in a few minutes. I have also worked with a number of major pharmaceutical and medical device manufacturers on serialization implementation. I developed, tested, and trialed the first use of data matrix in healthcare as a data carrier, and the first use of the 4-string data code that is now used as an integral part of all data coding and traceability standards. Your first speaker today will be Chris Doyle, a specialist consultant with software solutions provider at Lancer and a former colleague of mine at GS1 UK. After studying law at Cambridge in the 80s, Chris has developed an extensive experience in healthcare, having worked with the NHS as well as a number of pharmaceutical and medical device manufacturers. He brings a wealth of expertise from his career operations, commercial management, as well as sales and marketing functions. And most recently, he has been focused on implementing improvements in the NHS in the UK. Until 2014, Chris was head of healthcare at GS1 UK and a member of GS1's global healthcare leadership team. Your third speaker today will be Heidi van Siersvingels, and I am not going to say that again, who works for Videojet Technologies and is Pharma Sales Manager for Europe and the Middle East. Heidi leads a specialist group of the company's global pharmaceutical key accounts and is responsible for all the company's pharmaceutical and medical device businesses in Europe and the Middle East. Heidi has been working in this position for more than 10 years and brings significant experience of pharmaceutical and medical device packaging industry and operational technical issues that are at the core of most of the company's implementation strategies. Next slide, please. So, what I am going to talk to you about today is what we understand about barcodes and how this is likely to change. The core of everything we're going to deal with today is the data. All that a barcode is a data carrier, nothing more, nothing less. So Chris will very much deal with the data in element, and Heidi will deal with the data on element, which is the physical piece of how we print things. So next slide, please. What do we understand about barcodes? We all know something about barcodes. Every day, almost everything we buy, especially food and drink, has a barcode on it. Normally a linear barcode, normally a GS113, which has 13 digits as the name might imply. This is used to order in a shop or across the internet and is used to identify an individual product, and it is scanned or read at the point of sale or dispatch, where the scanner is used to check and link to a database that is used to look up that code. And it specifically looks up that code, that product data, that G10, which is a word you'll hear again and again as you deal with supply chain, pharmaceutical, medical device, track and trace, and serialization. So the scanner links to a database. This database contains thousands, probably millions of pieces of data. And it is then going to look up and find an exact match for that code, which it can do in real time extremely quickly, as you know from point of sale systems that work in supermarkets. This then allows that database to access a series of related pieces of information about that particular product that you are buying. Size, weight, color, content. This will both check that it is correct and make sure that the product you are buying, if you're at the point of sale, is the one you want. These pieces of information, which generally don't change, are called master data. And they are stored in very particular places in a system so that the scanner knows where and how it can connect to these and find that data. These storage places are called master data systems, which is one of the things that Chris will talk more about in a few minutes. But in addition to the static data, which doesn't change, there is usually dynamic data or changeable data. These are things that may involve dates, but more particularly, they involve things like price. As we know within supermarkets, prices on products change. The tin of beans may not change, the price of it may go up or down, dependent on market conditions. All of these systems that you see day to day are based on a single linear barcode, usually a 13-digit GTIN that can be scanned at the point of sale and used to check against a database. That's what you know from a day-to-day basis. But when we start to look at healthcare, things change considerably. Next slide, please. When we start to consider drugs, particularly prescription drugs, which up to date have rarely had any kind of coding or marking, apart from possibly batch or expiry date, we are now going to start to code these packs individually and uniquely. This is different. This is not talking about a single barcode that is the same on every pack as it is on a tin of beans or on a packet of crisps. It means that every code on every pack, on every item, on every bundle, on every case, on every pallet will be unique and will be different. And within those different data carriers, those data matrix, those linear barcodes that are used at different packaging levels, there will be a minimum of 4 separate pieces of data structured in a very specific way. So, whereas in food, beverages, clothing, a single linear barcode, a GTIN, will have 13 sometimes less, possibly 14 digits. When we start to deal with pharmaceuticals and healthcare, we're going to add to that expiry dates, lot numbers, and a serialized code. And rather than 13 or 14 digits, we're going to be adding at least 5 times as much data to every single pack. This will require both more movement of data, and it will also require more storage of data. So the lines, the printers, and the connectivity all has to be much more accurate and at a much higher speed. So what we're going to deal with today is how we acquire this data and how we use this data and how we print it and make it compliant to global standards. So over to you, Chris.
Thank you very much indeed, Tony, for that introduction. Can we have the next slide, please? So what I will try to cover in the next few minutes is a look at master data, and particularly how we manage master data. We'll talk in particular about how different data for different purposes needs to be managed in different ways. We'll take a brief look at the scale of the data challenge that's represented by the FMD and the DQSA, DSCSA. And we look briefly at industries who faced and met similar challenges. Tony has already touched on the world of grocery and retail, and we'll see what we can learn from them, if anything at all. Next slide, please. So, the good news is, I think, that the pharmaceutical industry in general has very good experience of managing large amounts of complex data and communicating that data through various channels. Examples I've presented here, for example, a summary of product characteristics or the patient information leaflet that goes in a pack. All of these pieces of information contain elements of data which are gathered from various sources and placed at the disposal of the person who requires that data at the end. But all of this data management is relatively static. It's end-to-end, single point, and once the right data is in the right place, then it's fairly easy to put in change processes in order to manage that data being updated. With this new type of data, particularly serialized data, we have a new challenge, and this is a dynamic data management challenge. And my contention is that at the moment, we don't have the systems in place, particularly in pharmaceuticals, to meet the challenges of that dynamic data management challenge. So if we consider master data as being the high-value core information that's used to support critical business processes across the enterprise and between trading partners. So this is the fundamental data that tells us what are our products. So things like attributes such as height and width and depth and various dimensions, the weight of things, and the various bits of other information which are required in order to identify types of product. Serialized data, though, I think is as important as master data, but it is by definition instance specific. So it's not type data, it's not telling us about a tin of beans, it's instance data. It's telling us about this tin of beans. Next slide, please. So I mentioned attributes, and attributes are the bits that make up master data. So what are these? The simple physical attributes we mentioned, dimensions and weight, etc. And we've all come across weight as a simple physical attribute of master data. If you've ever used an automated checkout at a supermarket and been told that there was an unexpected item in the bagging area, that's usually because the item you've scanned and placed in the bagging area, its weight does not comply with the weight of the product which is held in the master database. So there is already an instance of using master data in some way to verify a product. If you put something down which does not fit with the information stored about it, then the item will be rejected. In a supermarket context, that just causes a little inconvenience. In a pharmaceutical context, it will cause us to have to treat the product as counterfeit because it does not verify. So there's where I get my contention from, that data now is becoming as important as any other ingredient that you put into your product. So simple physical attributes, and then the more complicated and esoteric attributes, such as the amount of card and foil, etc., in the packaging, which will become very important from a green context when we look at recycling. And then pricing attributes, which particularly for the NHS in the UK, will become very, very important over the next few years as they seek to use the GDSN in order to exchange pricing information between manufacturers and users. So the take-home point from this is that the accuracy of these data attributes is as important as any other ingredient you put into your product. If they're wrong, then your product is no better than a counterfeit. Very important point. The next slide, please. So, standards for master data. I think we're all probably familiar at least with the name of GS1, and GS1 is a standards agency that set the standards for master data and for how it's shared. And the GS1 standard for data sharing is called the Global Data Synchronization Network, and the GDSN is one part of the GS1 system. And the GS1 system is effectively made up of these three elements: identification of things, the capture of the information about them, and then the sharing of required data. So identification is the numbering systems that GS1 manages. So we've heard about a GTIN, a Global Trade Item Number, and this is a 14-digit number which identifies a type of a thing. The capture of the information, this is the field of barcoding and encoding that information into a usable, readable, machine-readable form. And so that barcoding also includes radio frequency identification tags. And then the sharing element, we'll talk a little bit more about now, is the GDSN, the standards for sharing data. And the GS1 system extends beyond this also to sharing information such as business messaging, ordering, invoicing, and so on. Next slide, please. So who needs attributes from us? As users of data, we have customers, and in order to fulfill the needs of these customers, we need to supply them with various attributes. And some examples here, the Good ID, the Global Unique Device Identification Database from the FDA, focused on medical devices. In order to fulfill the needs of that, you are required to supply 82 accurate attributes. The NHS e-procurement strategy, which at the moment is generally focused on medical devices, but will very shortly turn its attention to pharmaceuticals, you need 115 accurate attributes, including pricing, in order to fulfill the requirements of that. The European Medicines Verification System, at the moment we believe 16 attributes for each master product that's placed on there, with an additional 8 for each market. And mostly focused on serialization for verification. And we can see here already different people needing different things according to what they want to use the data for. The DQSA in the States mostly focused on track and trace as opposed to verification. That at the moment requires between 40 and 60 attributes, and that's crystallizing as we go on and as we learn more about it. The GDSN, the Global Data Synchronization Network itself, there are 30 mandatory attributes in order to enter a product into the GDSN. And then, of course, there are other data bits and pieces which will be needed depending on the destination and the purpose of the data that you enter. And in addition to this, the one area where pharmaceutical companies traditionally trip up at first attempt are attributes associated with different packaging levels. So we're all familiar with a single pack being banded into an outer and then placed into a shipping case and then placed on a pallet. And each of those, the information about each of those packaging levels will need to be as accurate as the original one. Next slide, please. So where does this master data come from and where does it go to? So if we look on the left here, we have the various internal data sources, the ERP system, whether that be SAP or any other system. A lot of the data will be stored in there. There's finance systems, which will hold information about products, production systems as well from the manufacturing lines themselves. Various pieces of data will be generated there. But what we inevitably find when we go to pharmaceutical companies now is that much of the data that's required is held in informal data sources. And this is an area which really needs to be cleaned up before you set about any serialization process. And these informal data sources, for example, if we look at something as simple as the height, width, and depth of a pack, most people will refer back to the drawings of the pack in order to find out what they are. And as you can tell, the drawing of a pack will have dimensions for each face and so on. But once the pack is actually made up, folded with the cardboard and so on, then the size of it may not be exactly the same as was envisaged in those drawings. They're usually bigger by about 1 millimeter because of the way the cardboard folds. So things like that, where the actual information required simply doesn't live anywhere, need to be cleared up. If we take all of those pieces of data, and we look at the various people that will require it, retailers, regulatory bodies, and so on, and as we saw from the previous slide, all of these will require different elements, different attributes of that master data to be shared with them. Now, it's all very well, okay, here there are just 4 lines on this slide, and this is 4 instances of data sharing. But imagine every retailer globally, every regulatory body globally, every distributor, every hospital as a single one-off instance of sharing data. That's a huge number of manual shares. And manually sharing data like this is massively error-prone. And remember, any single element wrong, and the only thing we can safely do is treat the pack as a counterfeit. So in order to get this data to the right people in the right form, we need to look very much more closely at our processes of master data management. One of the key and most important ways we do this, of course, is by the markings on the pack. And these markings on the pack, particularly the GTIN, are described in the GS1 system as keys. A key to a database which gives us more information about the product in front of us. So getting these keys correctly and accurately onto our packaging is, of course, a huge challenge which has to be dealt with and got exactly right. And Heidi will come on to cover that in a moment. Next slide, please. So master data management then, simple as a one-off, new product forms to wholesalers and so on. Simple, straightforward to do one-to-one data management. But it's much more complex to maintain as things change. Currently, we treat these series of one-offs and we manage them ad hoc. But every time data is handled or transmitted, there's an opportunity for error. So we need to produce a dynamic, adaptive, and integrated system which will manage this data for us. If we look at the 2 pictures on here, we're all familiar and horrified by the counterfeit drug manufacturing operations that we see, as opposed to the high-tech and very clean systems that we know that people should use. But what I'd like you to think about is where on this journey from this terrible place on the left to this proper place on the right, where on that journey is your master data management at the moment? Could you honestly say that the master data is managed as well as any other product ingredient? Next slide, please. So a master data management system then would need to capture all the required data, organize it, enrich and validate it, collaborate across internal systems, and share that information with customers in the formats they require. And Sync Manager is one such master data management system produced by Lancer, and it already works with many of these data customers in order to deliver data to them in the formats they require. So master data management, using a master data management system, becomes a process to be managed rather than a series of one-off manual transactions. Next slide, please. So data lives in your internal systems and in informal systems around your organization. The management of that data is as important as the management of any other product ingredient. Incorrect data means tainted product. The way you organize, share, and enrich that data is now a fundamental business function. And taking that data and placing the keys to that data on your product in the correct way is the next big challenge. And that's what Heidi will address now. Thank you very much indeed.
Okay, so now you've heard how important data really is. Can I just clarify one small point before I do the summary on the presentation so far? Chris and I have both mentioned GTINs. I have mentioned GTINs to begin with as 13-digit codes used in food and beverages. Chris mentioned GTIN as a 14-digit code. The difference is that in healthcare, pharmaceuticals and medical devices, it is a 14-digit serialized GTIN which is used rather than the 13-digit which is in food. You will find the difference on those on the GS1 website and in the general classifications. But it is very specifically a 14-digit GTIN that is used in healthcare. Okay, so very quickly to recap before we go on to Heidi's presentation. Hopefully you now start to begin to realize how important data really is. It's not a casual side issue that you can deal with a bit later. It is a critical element of everything that you deal with in terms of your serialization and your traceability. As you are putting different data on every single pack that you produce on your lines, you need to check that the data is correct. You need to know where it is coming from. You need to know what is fixed data. You need to know what is dynamic data. You need to have a clear understanding of the structure, because the two critical things that you do need to understand is where is the data going to come from and how you're going to physically change that data into a structured, mechanical, machine readable code, barcode, maybe an RFID tag, but always with human readable element which needs to be printed onto pack at some point. This is the second most critical element. We now hopefully understand a little bit about where data is coming from. Heidi is now going to explain what we do with that data as we apply it or print it onto packs, cases, pallets, and other elements. So over to you, Heidi.
Thank you very much, Tony. If you could please go to the slides with the three elements data in, on, and out, please. So in this section of the webinar, we will describe the element data on, being the art of printing data either directly on an item or applying a label to it. The coding bit is just a piece of the puzzle of the whole serialization process, but it is an important one. What I will cover in this section is how to translate the data into a printed code, how to ensure the quality of this code, and finally some practical tips on dealing with the challenges of implementing and selecting printing equipment. We learned already today from Tony and Chris that the data management process of serialization programs consists of three key elements. Number one, data in. Gather or generate the data from different sources and link or streamline it as clearly explained by Tony in the first module. Number two, data on. Transmit that data to the printers on your production or packaging line, which is then translated by the printer software into barcodes and alphanumeric human readable text. And finally, number three, capture this printed information, verify the quality using vision systems, barcode readers or scanners, and transfer this data to a certified data pool to store and report, a topic which we will discuss in detail in the following webinar. At Videojet, we deal with the data on part, but ideally, we like to be integrated into the whole process of data in, data on, and data out to provide a complete and compliant solution for our customers. Next slide, please. When regulators started to consider how to make the healthcare supply chain safer and more secure, it became clear that more data needed to be printed at each level of packaging. In addition, with the high risk of counterfeiting and substitution of products within certain supply chains, it was necessary to be able to track and trace pharmaceuticals from their point of manufacture and packing to the point of consumption by patients. As we learned from Tony, traditional linear barcodes that we're all used to seeing on items we buy at supermarkets can only carry limited amounts of data within a single code and are physically large, often too large to print on small pharmaceutical packs or bottles. So what was needed was a smaller, more robust data carrier that could hold more data, more securely, and which was less prone to damage than linear barcodes. At present, most of the regulations, whether it's the Unique Device Identification, the Drug Supply Chain Security Act, or the Falsified Machine Directive, they require a 2D barcode at item or pack level. Why? Thanks to its robustness and capability of containing large amount of data, limited size, and its omnidirectional reading capability. The picture on the screen shows a comparison of a linear barcode and a GS1 data matrix code containing the same amount of data. As you can see, the data matrix code has about 1/10 of the length of the linear code. Next slide, please. So let's have a detailed look at the most common type of 2D code being used, the ECC 200 data matrix with GS1 data structure. ECC stands for error correction code, allowing as much as 30% of the data to be damaged or missing, and still allow capturing the data contained in the barcode. This barcode is easily recognizable by the fact that the upper right corner, so positioned in the upper corner of the L-shaped pattern finder, should always be a white cell. Typically, 4 or 5 separate data elements are being combined or required. A product code, in this instance, a global trade item number, an expiry date, a lot or batch number, and a unique serialized code consisting up to 20 alphanumeric digits, which will be unique for each individual item or pack. A national healthcare reimbursement number can be required by local country legislation. To identify these 3 data elements, prefixes called application identifiers are used in order to attribute meaning to the data encoded within the barcode. For instance, the global trade item number, the GTIN, is identified with a 01. The serial number is identified with 21. In the example shown, the data matrix appears with a 4-string code written in a single line using application identifiers, which always appear in brackets. They serve as breaks between each piece of the code, indicating to the software what type of data is being coded. The human-readable text could appear stacked at the side of the data matrix rather than below as well. Whatever printing technology you use, ensure it offers tools to select the appropriate barcode types and standards to enable automatic creation of the correct structure, format, and size. Next slide, please. Once the data has been printed onto the items or packs, you will need to verify the quality of the print. The ISO 15415 standard identifies the method how to evaluate, measure, and grade the quality of the 2D barcodes. There are 7 parameters being evaluated beside the fact if the barcode corresponds to the required data structure of, for instance, GS1 standards. One is print growth or loss. This could be happening on certain porous substrates, like Tyvek, causing ink to bleed, making the ink overlapping the adjacent cells. Another being checked is the remaining error correction availability. Dust, stains, humidity could cause parts of the barcode to be damaged or disappear. Symbol contrast. Often the material onto which the barcode is applied affects the contrast. Printing onto glossy material could cause light reflections, so the barcode reader may not distinguish properly between the dark and light elements. This can be solved by selecting appropriate lighting. In this case, diffuse lighting could be used. Another parameter is modulation. For instance, the dark elements could vary in color caused by uneven distribution of ink or uneven laser marking depth. Fixed pattern damage refers to the damage of the quiet zone, finder pattern or clock pattern, which can severely inhibit readability. A quiet zone or no printing zone is necessary around the barcode to allow the scanner to properly read. Damage can be caused by movement of the product or vibration of the line. And finally, axial non-uniformity and grid non-uniformity cause the barcode cells not to be nicely squared but distorted. Again, typically could be caused by unexpected movement of the product while being printed, vibrations of the packaging line, or variations in line speed. Next slide, please. It is important to note that the ISO 15415 standard specifies that code quality test must be carried out at standstill, and the overall grade is the lowest grade achieved on the 7 key parameters. For instance, on the Falsified Medicine Directive, grade C or 1.5 is considered as a minimum. Next slide, please. Product waste due to poor coding is highly undesirable, so how to minimize? Some practical tips on dealing with challenges deriving from implementing serialization. One of the most significant considerations is the handling and application of this data to the package. The more stable your packaging line, the better quality codes. Minimize vibration of your lines, ensure stable movement of the product and consistent line speeds. Upon selecting a printing technology, consider the shape of the product, space and distance to the product, and marking time you have available. Ensure your print speed matches your conveyor speed using encoders on the line or product centers. Many root causes of poor quality barcodes are related to poor handling. Next slide, please. Ensure your printing solution is future-proof. Avoid unnecessary cost of investing in new equipment each time a new requirement is popping up, asking more data to be printed, and your printer cannot handle the extra data due to the marking time or data handling limitations. Ensure whatever printing technology you select, it has a decent buffer capability and quick response time handling data, like for instance the Volker Thermal Inkjet M600 OEM. It has happened in the past, just thinking of the CIP regulation in France, which did not require a unique serialization number integrated into the 2D barcode, as the goal of the CIP was to target reimbursement fraud. Companies invested in printers which were not serialization capable and have to invest now to comply with the Falsified Medicine Directive. Or if you are a CMO, CPO facing pharma companies with diverse coding needs, ensure you have a versatile printing solution. In addition, the trend is that production speeds continue to increase, so make sure all your equipment on the packaging line can follow and has excess speed capacity, and it's not causing the limitation for your production line speeds. Next slide, please. Implementing serialization offers an ideal opportunity to investigate whether to reutilize existing hardware or invest in new equipment. In the latest IQ Serialization Industry Report, almost 42% of the people quoted that optimum utilization of existing technologies and machineries was their biggest operational challenge while implementing serialization. Investing in new equipment could help improving TCO, whether it's because a printer can offer tools reducing ink consumption or improving overall equipment efficiency by reducing line stop and changeover, or even support you in ensuring the right code is printed in the right place on the right product, and thus reducing operation errors. Investigate if your existing printing equipment can be integrated into the serialization model. Is there enough space? Can it communicate? In the end, it might be cheaper to invest in a new printer. On the other hand, keeping existing hardware, which may be standardized throughout your organization and operators are familiar with, could save you implementation time and money. Next slide, please. Another challenge is to ensure your code lasts onto your product and remains readable during its lifetime. Many companies do not realize what a major impact varying substrates or materials can have on printing quality and operational performance. If you're working with a printing technology using ink, select your ink and carton material, taking into consideration decap time, dry time, light fastness, scratch and water resistance, and ensure to test all your carton materials types being used on your packaging line. Next slide, please. There is no one-size-fits-all technology for printing variable data. All technologies have their advantages and disadvantages, depending on the material type, integration space, line speeds, environments, etc. For printing onto folding cartons, selection could be made between thermal inkjet, continuous inkjet, and laser. The most common printing technology for printing onto pharmaceutical folding cartons nowadays is thermal inkjet. During the last decade, thermal inkjet has proven its reliability because it's a clean technology, no risk of ink spills compared to a continuous inkjet, just compact, not complicated to install, and easy to operate. You do not need to be a rocket science engineer. But most important, it offers high resolution codes up to 600 dpi at high printing speeds of up to 20 pharma records per second and unbuffered mode. But if your primary requirement is a permanent code and you want to avoid the use of supplies, then laser technology might be your best option. Different laser types are available, from CO2 lasers, fiber lasers, UV lasers. Selection will depend on the type of material needed to be marked. This could range from HDPE bottles, blisters, vials, aluminium, foils, stick packs, syringes, and a wide other variety of materials. The advantage of continuous inkjet is that a wide selection of inks are available to adhere to virtually all types of materials and any form of shape. Gather advice from your supplier in order to consider various coating technologies for your specific application and ensure you sample on all your different materials and packaging types. Next slide, please. Summarizing. Governments around the world are in the process of deploying regulations in order to combat counterfeits. Every region or country may have its own nuances of traceability regulation. All companies, which are manufacturers or license holders of a healthcare product, regardless of their size, now have a fixed period of time to make some critical decisions. You will need to understand the requirements of all the markets you supply to, what is needed to be done, by when, as well as what cost implications are involved, and consider all aspects of future requirements. Pharma packaging lines in the past just required simple data information like expiry date or batch number with few quality requirements, just that it was readable. And linear barcodes came often already pre-printed on the cartons. Now, each package will contain unique data. The ability to assemble data from various sources, high-speed printing this unique data, and verifying the quality and content makes this activity critical. The reality is that time is running out. Action is required now. Thank you for listening, and I now kindly hand back to Tony for the Q&A section.
Thank you, Heidi. Can we move on to the next slide, please? Okay, I'd just like to spend a couple of minutes summarizing what you've heard in the presentations this afternoon, and then I will go on to a question and answer session. So just for a few minutes, I hope that you've now grasped how important data is. This is not a simple case of I have got to print a code, a barcode, a data matrix on a pack, and that's all I need to do. It's much more complicated, but provided you have the right systems, the right understanding, then you can make sure that the solutions you put in place will meet the current and future standards, regulations, and legislation. You heard from Chris about the importance of master data, of static data, key elements and attributes that don't tend to change. You've also heard about dynamic data and Chris's new serialized data, data which is very instance specific or even event specific, that unlike master data can change, but is actually critical to a time, a place, an event that might well happen and that needs to be recorded. These are situations that haven't been recorded anyway in the past, but will be in the future and need to continue to be. Chris spoke at length about data attributes, physical attributes, packaging, pricing, and other elements. Elements like sustainability, the amount of packaging that's used, the type of packaging that's used, the recyclability of packaging. These are not yet within legislation or regulatory requirements, but they are likely to be coming in the not too distant future. So need to be considered and should be thought about, not just in physically the packaging and other materials you use and which printing and application technologies you might need, but literally about sustainability and environmental issues. We've heard from Heidi about the data matrix ECC 200, which is pretty much the standard 2D code which will go on an item level. It's really at the core of global serialization. And the 4-string codes that are needed, the pieces of data that go into that data matrix, both as a machine-readable code and as human-readable information. You need to understand where you get that, how it is structured, and how you're going to link that to your printing equipment and your scanners and reading equipment to make sure that you printed the code with the right information to the right quality. And in order to do that, you need to make critical decisions about the types of technology and the types of solutions that you will need to integrate a complete solution along your lines. So really, the message today is understand about data, understand where it comes from, where it's going, how you use it, how you store it, how you format and handle that data, because it really is at the core of everything you do. And as Chris said, if you get even the smallest part of that data wrong, you will end up with products that are actually no better than counterfeits. Thank you for your time today. I'd now like to move on to some questions and answers. And I'd like to start with a question to Heidi, which says, where or how are serialization numbers generated?
Okay, well, usually they are generated from a unique number generation module, which the manufacturer or producer will own. This number normally not exist in any database or repository, so it's generated specifically for this purpose. Some ERP or best software may include this number generation modules, but often manufacturing packaging companies use a separate module with their own unique generation algorithms just to ensure security and control. There are some exceptions, like we know for Turkey and China at this moment still. Those unique numbers are being provided by the government towards the companies.
Thank you very much. Okay, next question for Chris. We've heard a mention, Chris, today about CFR 21 Part 11. What I need to ask you is, do all systems have to be compliant to what is Central Federal Regulation, i.e. CFR 11 Part 21? Over to you.
Yes, so the Central Federal Regulation that you refer to sets various standards for the information that has to be managed into federal systems. So if, for example, you were placing information into the Good ID database, then the systems which manage that data, the systems of reference internally in your company that manage that data, need to be part of a process which is CFR 21 Part 11 compliant. So I'm always very suspicious when I see systems which bill themselves as CFR 21 Part 11 compliant. A system in itself cannot be. The things which you have to look for compliance to are your processes. And of course, systems will form part of those processes, but focus on the process as the compliant thing rather than any individual system as a compliant thing.
Okay, thank you very much, Chris. Next question for Heidi. You talked in some detail about data matrix two-dimensional code. One of the things that I think we might need to clarify is what is the recommended dimension or symbol size for 2D barcodes in order to give us both a good quality of read and an ability to hold the amount of data that we need to have to comply.
Okay, well, if we take, for instance, the Falsified Medicine Directive as a basis, so that regulation requires a serial number, batch expiry, GTIN, and depending on the country's reimbursement number. So to be able to encode all that data, a minimum 2D code with symbol size of 22 by 22 would be needed, because that has the sufficient data capacity to encode 60 numeric and 42 alphanumeric characters. If you look then on the print side, ideally printed with a module size of 0.4 millimeter or a 15 mil module, as we also call it. Just for clarification, 1 mil is like 1,000th of an inch. So that will give you a barcode height and width of 8.38 millimeter, which should be well readable by an ordinary hand scanner. If you can even print it bigger, go to a 20 mil, that would be even great. So a cell size of 0.5, that's even better. But normally already starting from 0.4 millimeter cell, that should work nicely.
Okay, thank you very much indeed. Okay, back to you, Chris. You talked about the need to build an integrated system and possibly have a master data management system to handle and bring together all this data. But do your internal systems have to be interoperable in order to use a master data management system?
The majority of master data management systems you can buy now will already have come across the various bits and pieces that are required to be interoperable with pretty much any internal system that it comes across. Really, what a master data management system can do is overcome the need to make internal systems interoperable. They can gather information from different sources in different formats and reformat them and send them out to in whatever required format the customer needs. So really, a master data management system removes rather than increases the need for interoperability.
Okay, thank you very much. Heidi, a third question for you. I'd like to just go back to the point we talked about bringing data in. Obviously, if we're going to bring dynamic as well as static data onto the line to print onto packs that are running down the line at high speed, we can try and do this in real time, but obviously if there's any problems such as connectivity, this might be an issue. One of the ways I know that you manage to handle this is to build a buffer within the printer to store the data ready for the printer to use when it's ready. How much data generally would an online printer hold to make sure that it can continue to run at high speed?
Okay, thank you for that question, Tony. Well, this can vary from printer to printer manufacturer and to printer technology type. If I can speak about our product range, if I look at our thermal Wolke inkjet printer, which is made especially for serialization, it has a very big buffer. The buffer size can contain up to about 100,000 pharma records, so it allows a huge flexibility. This is an overshoot, but you never know what happens in the future. Comparing to, for instance, the laser type, they have a buffer of about 100 pharma records. Again, it all depends how the customer wants to work and how the integrator OEM wants to work. Some cells send the data over one by one, some send them over in batches by 10, and other want to send them over in batches by 100. But we just make sure that, well, whatever you ever select, it just can hold a nice buffer, whatever something happens, just like you explained, if you have an interruption.
Okay, thank you very much. That's great. Good answer. Okay, last but by no means least, Chris, one of the questions that comes up regularly about data carriers, we talk about barcodes, but of course there are other data carriers such as RFID. Can we use RFID to meet requirements in FMD or DSCSA, for instance?
For DSCSA, yes, you can. It's specified in the legislation. I'm sure it will also be for FMD, that you can use an RFID carrier. The only difficulty with an RFID carrier at the moment is that very few people have the capability to read them. They are exclusively machine readable. They have the advantage of being non-line of sight readable, so if you have 1,000 of them in a case, you can read them all without having to take them out and visually see them. But as I say, the difficulty is not many people have the capability to read these things at the moment. Barcode readers and two-dimensional barcode readers are almost ubiquitous. Most of us carry a mobile phone, which are some of the best barcode readers in the world at the moment. But the ability to read RFID tags amongst the customer base is something which isn't there at the moment. As they become more used, and I think the first place they will become more used will be in distribution and warehousing and wholesalers. As they become more used, there will become more demand to do that. But for the moment, it's not a requirement, but yes, you can meet the requirements like that if you wish to.
Okay, thank you very much indeed. That pretty much brings us to the end of the presentations for today. Firstly, I'd like to thank Chris and Heidi for their invaluable contributions to the data in, data on presentations that we've given you today. We hope you found it useful. As I said, this is part of hopefully an ongoing series into the future. We welcome your feedback and comments, questions, topics you may like to have discussed in future seminars, webinars, presentations that we might consider trying to put together with other experts such as Heidi and Chris. But for this afternoon, I'd just like to thank you for your time, trying to put together with other experts such as Heidi and Chris. But for this afternoon, I'd just like to thank you for your time and contributions.